Hello, ladies and gentlemen. Welcome again to a Love2D tutorial where we're going to have a lot of fun. I'm just kidding about that. Strange little voice. Last time we were making UI. Wonderful, lovely UI. We had implemented a checkbox. And what a lovely checkbox it was. We went over some of the possibilities, some of the options here that you could utilize for this. So we have this nice little UI controls, and I think it's about time that we move on and we start looking some more at how we might implement the movement of our player. And with that in mind, I want to switch to this scene, and in order to do that, instead of having to click that start button every time, I'm going to come over here to main, and instead of switching to the main menu right here, I'm going to uncomment this switch to test so that now when we run it, we get the following, and that is the little fella moving. So we'll start with that, and we'll move into test.lua. And instead of starting him walking, I'm going to go ahead and start him at idle, because I think it would be nice to just have him standing there as he has been before, and we still have the punch. Okay, so I want to add just go ahead and quickly add a jump animation. It shouldn't take a really long time. Let's go into the assets folder and we'll grab the hero. I want to reveal and explore it. I'm going to grab the hero PNG file. I'll open it up in paint.net. And we'll come over here like this. I want to make him jump, and I think I want to use this little single frame animation right here. So if we go and we look in our test, we have an idle, walk, swim, and punch. And if you look, these are the X and Y offsets into the, if you remember, into the image. And we've said that all of these start at 16. If I did a selection, we probably could see that'd be 17 and that's 16, and so that would be something like that. Or actually it would be something like that. So that's what we were looking at. So 16 by 16 is idle, and that is this top set right here. And then 16 by 32 is walk, which is this set. And then we have a 16 by 64 or 16x offset, y 64 offset, which is swim. That's got to be this one. I want this one, so that means that we'll do a local jump, and that will be an animation, and it will be 16. And since our guy is 16 by 16 cell size, we will actually move him up here, and that'll be a 48. We're just going to add another 16. And of course, the size is still going to be a 16 by 16 cell, as we said. The number of frames will be 1, and the number of columns doesn't really matter because we only have one frame, so we're going to put it at 1. The number of, or the frames per second doesn't necessarily matter because, once again, we only have one frame. And I'm going to say that loops because it does. Okay, so now we have the jump animation in, and if I were to call it, let me show you. Let's start with the jump animation. And you'll see that there's nothing. Oh no, it's a bug! No, it's not a bug. It's okay. It's not exactly a bug. But we need to be careful here because remember this animations table that we can add animations to, we need to add it here. Well, I want to be told whenever I try to load an animation and I don't have it in my table. So in order to do that, let's go to the sprite module. And up here in the animate function, let's see. Let's look at this. So if the current animation is not equal to animation name, and the self animations, so we're looking in that table to see if it's not nil, then we do all this stuff. But we want to look and see if self.animations, basically we want to take this let's take this, right, this whole thing, and instead of not equal to nil, we want to know is that not found? And if it's not, then let's just do an assertion, because that just works. So we'll assert false. We'll of course always assert, which is what we want, and we'll say that animation name ... animation not found. How about that? Show you what that looks like when we run it now. We will now see that the jump animation is not found. So that just makes me feel a little bit better that I won't just be running around with my head cut off trying to figure out why in the world that animation isn't working whenever I call it, instead of just being plain old blank. It actually gives me an error. So with that, let's add that in here. Let's add in the jump animation. Jump equals jump, ladies and gentlemen, and now we should see the little guy flying like a little angel. So we'll go back to idle. And that's great. So we've got that, made that little modification to the sprite class. And now what we probably want to do is, well, here's some things, guys. That is, we could go in here and we could say if the key is else, if, say, the key down, let's say right, so we want to walk right, and we have to do stuff like this, and sprite.current animation is not equal to punch, because whenever he punches, we want to let him finish that punch animation before we start walking, right? Then we're going to do sprite animate, let's say walk, etc. And if we run that, it's going to be really weird because, you know, and then see, I just let go. Doesn't work. We got to, instead of key down, let's do key. And then that should be good, right? It's only when we press the key does it, but I let go of the key and nothing happens. Well, that's because we have to check if we're walking and the key isn't pressed, then we want to go back to idle. That sounds suspiciously like a job for a state machine. That's right, kids, a state machine. Ladies and gentlemen, let's make one of those. Let's do it somewhat generically, if you will. We'll have some of the implementations you'll see have something of the nature of, let's go ahead, I'll show you what I'm talking about. Let's go ahead, add it into our lib folder here. We'll do a new file and we'll call it statemachine.lua, because Lua is the stuff that we're working with. And I'm going to go up here and I'm going to steal this stuff here like I always do because I don't want to type it. Change this to state machine, and we'll do a shorthand for state machine. That'll be SM, and then we'll return SM. Probably don't need vector. I'll comment it out just in case we may want it. So what typically you see whenever you do state machines is you'll have a transition state. So you'll have an enter state for the next state, and then sort of a current for the current state after it's gone through its enter phase. And then when you want to change a state, you have to exit that state, and that's typically called once before you begin the next state. So you'll see something like this. You may see something like function. We'll say, what should we say? Let's just do idle. So we could do something like idle enter, and then we could do a function, and then we could do a function idle just plain old idle. How about that? And we could do end, and then we could do a function idle exit. So that's typically the way you see it. Now the question is, do we want to do this? Do we want this, or do we want something more like, and we're just messing around here. We're looking at how we might do this. So that's a possibility, but that is that's up to 3 functions per state, which maybe that's what we want to do. We may end up going with that, I don't know. Or we could do the following. We could have one function such as this Then we could say something like if, say, self.transition, we'll call it a transition because that's what it is. If the transition state is, say, transition dot, if I can spell transition right, transition dot enter, then do something. And then we could say else if self.transition equals transition dot none, then do something. And we could of course say else if, or we could just do else if we only have those three. We would do an enter, a none, or this would be transition dot exit. And then we could say do exit stuff. And we could do this, do enter stuff, just like that. I don't know. I'm sitting here right now and I'm thinking, all of that, typing all of this, if, else, blah, 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 blah. I don't like it. I'd rather do that once. Maybe this is the better way to go. Maybe this is the better way to go. Well, let's set up some things anyway. Let's declare a global. Let's declare a global for our transition. Well, no. Wait. We don't have to declare. Okay. If we do this, then this would be an implementation. So we would derive from the state machine class here, and this would be a particular state, say the idle state, like for our little guy that we were just looking at. And then we would have to check these transitions, and we would need some sort of global that had definitions like transition, enter, such as something like transition equals a table where you have maybe none equals, you could even do 0, or you could do none equals the string none, and enter equals the string enter, stuff like that. And of course you would do exit, I don't know why I'm typing this, equals the string exit, etc. You could do that, but then of course you have to make it global so that your derived functions can see it, because they're going to need to do this comparison every single time. And with that in mind, I think that we may want to just do this instead. So what we can do is we can make this transition table a local table. That makes it nicer. We could have a transition states of enter, and I'll call it none, which will just have no addition. And what we'll do is we'll just prefix our functions by these things. So it'll look like this. So we'll not do this for our states. We'll end up, this is how we'll implement our states. We'll end up doing it like this. So if you want an enter function, you do it like this. If you want an exit function, you just add underscore exit to it. So an enter would be an underscore enter, and exit would be an underscore exit. See what I mean? Yeah. So I'll comment that out. Remember, that's derived class implementations that we're looking at. So that's I think that's kind of what we want to go for. I feel like that's going to be a little cleaner, a lot cleaner than doing this for every deggum state transition that you want to do. That feels, it looks like it's definitely less to write. So let's go with that. All right, let's do our new function. We'll say function, and I forgot the function keyword, didn't I? Function sm new, and let's say state. So we'll take a parameter called state. We'll do an end, and what do we need here? Well, we need perhaps something like self.state equals state. What if we want to reset all of this stuff? We probably need a reset function. Let's do a reset function. Reset, And let me check real quick. Am I using capitals? No, okay. I'm doing it right. Small lowercase letter there for function name. So let's do a reset, and let's say self.state. We'll set everything to nil. We'll have a previous state, so we'll just call that previous. It also equals nil. And we'll probably have that same transition. Transition equals, we'll do transition dot none, like that. Okay, so what we can do to set up our variables is we can just call self, reset, and then we'll want to do something like self change to that state, something like that. And we need to write a function to change to the state that we want. So let's do sm change and the state name. And here's where we want to definitely be really careful, because well, first thing we want to do is we want to make sure that that state name is input. The input state name is a string. So let's assert that the type of state name is equal to string. And instead of state name, let's just call it state. Less to type, ladies and gentlemen. It's less to type. And I'm all for less typing. So if it's not a string, then we'll say parameter state must be of type string. Isn't this so exciting? We're making a state machine class. It'll be great. Then we'll make our player. We'll derive our player from the state machine class, and we'll add all that stuff in there, and then we'll see just how much nicer it all is. So we want this thing to be a state, the state to be a string. And then we want we also want to assert that, yes, we want to assert that probably that the state, because we want to be able to change the state to nil. We just do. So we want to say either the state name, oh, and I did it again. Sorry, state, that should be state. So either the state, the new state should be equal to nil, which probably will cause this assert to trip first. Is there a nil type in Lua? I don't. Yeah, I mean, I guess there is, right? Let's check real quick. So we'll say Lua types. There probably, I'm sure there is. It's got to be. So you can do type nil. Yeah. Okay. So if type is, we want to make sure it's a string. Let's say or type state equals nil. Of type string or nil. So if the state is nil, or so we're changing to the state, so that means we could even either have whatever the state name underscore enter, or just plain old the state name. So the state could have an enter function, or it doesn't, and it just has just a sort of a none transition function. So that means that in our table, which we're using for class stuff, our function will be in here. So we'll say if self state we'll say put we'll do underscores here, because what we can do is we can just do the following. We'll say transition dot enter. Transition.enter. So that will give us whatever the state name is underscore enter. So that's what we'll look for. We'll look for something like this. So if that is not equal to nil, or self state is not equal to nil. Okay, so any of those, and we'll just say can't find state as a state function. I don't know that I like that logic very much, but anyway, we can come back to that. So what we would like to do is we do want to save the previous state, so we'll do self.previous equals self.state, so that gives us the previous state. And then we'll say self.state equals state. Yes. And then we'll say, and we probably want to be able to change immediately, which I would think a change, so let's change this to change immediate. So this changes to a state without calling the previous state's state underscore exit function. How about that? All right. I'll show you what I mean here a little bit later. So we'll have a self.transition, and we'll say that transition, well, we'll have to check now, won't we? If we change immediate, we'll do this. Let's do that. Let's just do it like this. If the state has a transition enter function, then the transition equals transition dot enter. Okay. You see what I'm doing? So if that state has an enter function, then that's what we want, right? Else if, well, actually, we know from this assertion that it's going to have this could get a little hairy, and as such, let's take this out. So we sort of require now, the way that I'm doing this here, we require that either the state name be nil or that the state have just a none transition function of the same name. See what I'm saying? So if you have a state called idle, you must have just a plain old idle function. You can't just have an enter and an exit. You have to have this function. Okay, so that makes things a little bit simpler. So if we don't see an enter function, an underscore enter function for that state, then based off of this assertion, we know that self.state in the table is not going to be nil. So the self.transition is going to equal to transition.none, because it won't have a transition. That makes sense? I hope it makes sense. So we've got this change immediate, which changes to a state without calling the previous state's exit function. So then we need a function called the same thing that we were going to call it, which is just plain old change. And we got to change to that state that we want to change to. And then we can just turn around and immediately call change. Change is good. Change immediate. And then we can do the same thing here, but for the previous state. Hopefully that makes sense. So we'll check to see if the previous has a transition exit, then the self-transition is going to be transition exit. My goodness, what are we getting ourselves into? This is going to be a bear to debug, isn't it? So first, we do the change immediate, and then we want to call that exit function to the previous state, and we also want to say if previous is not equal to nil and that function, whatever previous state's name underscore exit is actually in our table, then we will say yes, we want to call transition exit. My goodness gracious, how about that? Hopefully that's going to work, I'll tell you that. Now, something else we might want to do, and that is we may want to say if the state equals previous, then return. See what I mean? So we don't want to just change the state and then go to the state again and change back to the state again and change back to the state again. I don't think there's any reason to ever have to do that. But of course, if there was, we could say force. So if state equals previous and not force, so then we could say force equals force or false. I think that'll be fine. What is not nil? Is not nil true? Tell you what, let's not worry about that right now. Let's just assume that if that state is the previous state, then we don't do anything. So we could say to do allow forcing a state to change to itself. How about that? That makes me feel pretty much better about that. How about you? Yes, 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 indeed. Okay. And we'll make this a component, which means it will need to have a draw function, which really won't do anything here. But that's a conjunction, ladies and gentlemen. So we will have an update function, and that update function will indeed do something. Because what it's going to do, ladies and gentlemen, it's going to do the state change. So we can do this. We'll say if self.transition equals transition.exit, right? And so we've already checked all of that stuff up here. So we know if we have an exit, and then, is that true? We did. We have right here, we said self.previous transition exit, and let's just go with this. We may have to change this around. There may be some bugs here. There may be bugs here in this code, ladies and gentlemen. But I think we're getting all of them. So if self.transition equals transition exit, then let's call self.previous, or that previous function. We'll pass in our self, because normally we do the colon, which is implicitly passes in self, and we're gonna say that for these states we're gonna pass the delta time into them, just because that's a useful thing to have. So then we'll call that self previous self.transition. See, so we'll call the underscore exit basically. And then we will set self.transition equal to transition.none. Okay, you see what I'm doing? It's fun, right? We like it, don't we? Okay, so else if self.transition equals transition.enter, then, and remember, we've already checked to see if that state exists, so we should be okay to call it here. Then we'll say self state, and then we'll combine that with self.transition, and then we'll say self. So we're calling that state. And then we'll set self.transition equals, and this is wrong. We're going to say enter, because we've exited this previous state, and then we want to go to enter for the next time that update is called. But this one is going to be transition.none, just like that. And okay, we'll also have to say else. Basically, if the transition is none, then we just call self. Else if self, or if self dot state not equal to nil, then I'm still in the parentheses mode, aren't I? Self dot state, and I need to add a self here, and I need to add a self here, don't I? So we're going to call that self DT, which is going to be basically this will be state underscore enter. DT is what we're going to be calling here, and we'll say this is calling previous state underscore exit, right? OUS. And this one is calling state DT. See what I mean? See what I mean, ladies and gentlemen? So if we have an exit transition, if the transition is an exit transition, then we'll take that previous state and call its exit function. And then we'll set the transition to enter. But you know what? We only need to set the transition to enter if the new state, oh my goodness, this gets to be a wall of wax, doesn't it? If self.state not equal to nil, and oh, and look, I messed it up here too. I need a self there. Now, let's do this. Let's just grab this. Oh, and we also say, we need to say if self here, if self.state is not equal to nil, and see what I mean? We can pass nil in here. And we don't want that. So it can't be nil. Otherwise the transition will be none. And let's just copy this. I hate copying blocks. I hate copying blocks of code, but sometimes it's necessary. Okay. So let's put that here. Like a gaggle of mess, doesn't it? But I think it will still simplify our lives. A little complex code versus simpler code. So if we have a current state, it's not nil, and then that state has an enter function, then set the transition to enter. Otherwise, set the transition to none. You see? You see, ladies and gentlemen? Then perfectly. Else, if self.transition equals transition enter, here, then we'll call that function just once, and then set the transition to none. And then if the current state is not nil, then we will continue to call the regular plain old state DT function. Does that make sense, ladies and gentlemen? I sincerely hope that it does. Let's run this just to see if there's any errors, and even though I'm not including it in anything. I just want to see what goes on here. Okay, nothing is happening. Fantastic. I'm looking at the clock, ladies and gentlemen, and I'm seeing that we are about 34 minutes. I'm going to cut this episode here, and when we come back, we will implement a player class utilizing this code, and we'll have lots of fun. I'll see you next time.